Hey, this is the last video for 3.5. This is 3.5c, and we're going to talk about odd and even functions. So functions can either be odd or even or neither. They can't be both. It's odd or even or neither. So the definition for an even function is that if I plugged in negative x, I would get the same thing as if I plugged in x. Okay, so let me give you some examples of that. One of our basic library of functions, the square function, looks like this, right? Well, if I plug in negative x into that, well, I have that negative squared, right? It's the same thing as x squared. Okay, so this is an even function because it's the same. Whereas, you know, if I were going to look at, let's do g, x cubed, and I plug in negative x, well, then I have these three negatives, and so that is the same as negative x cubed. Okay? So that one is not even. So this is an even function. Now, you probably can imagine that anything, you know, that had an even exponent is going to end up being an even function, because you'll have this even number of negatives when you plug in that negative x. So the real question comes in is when we start combining these basic functions, right? So let's see if we have some function that combines several things. Say we have like 2x squared plus x plus 4. Well, when I put negative x in there, right, you notice that I get, so my negative here is squared, so that makes it positive. So that one is just like a 2x squared. This, though, does have a negative x, and then plus 4. Okay, so is it exactly the same? Well, no, this is a plus x, and this is a minus x. Okay, so this is not even. Oh, funky. It has to change. It has to be exactly the same. Every single term, it has to end up exactly the same. So an odd function means that if I plug in negative x, I get the opposite of whatever f of x was. So that would be an odd function. And we already looked at one that was an odd function. That's at x cubed, right? It's because if I plugged in negative x and cubed it, that would be 3 negatives, so that would be like negative x cubed. And so you can see that this is exactly opposite of this. It's like a negative. So when we have several terms to look at, everything has to be the opposite. So if we were looking at the function 3x to the 5th plus 2x to the 3rd minus 7x. Well, when I put in that negative x you see what happens, this has an odd number of negatives, so that would leave it as a negative. And this has an odd number of negatives, so that would leave us a negative. And then we have negative 7 times negative x, and that would be plus 7x. And you notice that the original was positive, and this one is negative. The original was positive, and this one is negative. The original was negative, and this one is positive. So every single sign is the opposite. So that means this is an odd function. Okay, so when we are checking these functions, you don't have to, plug it in and show all that work if you know that it's changing by looking at the exponent, but you really do have to look at every single term. So suppose we have this, well, let's do like 3x cubed minus x plus 3. Okay? So when I plug this in, I plug in a negative x. So this has a negative, and it's to an odd power, so that would be a negative 3x cubed. And there we have a negative and a negative, so that would switch that sign, and then we just have plus 3. Okay, so that means we had positive, and now we have negative. We have negative, and now we have positive. We have positive, and now we have still a positive. Okay, so this made it so that it was not an odd function. So this is neither even nor odd. We can't say it's even because some of them changed, but all of them didn't change. So it's not even and it's not odd. So that's the thing that you have to remember is when you have a constant, it's kind of like having x to the 0 power. And 0 is an even number. So a constant is an even function. So we have an odd one, we have an odd one, and we have an even one. So that would be neither. It's neither even nor odd. So I want to look at what the graph of an even function looks like. So x squared, that's an even function, right? So that means if I plug in 1, I get 1. If I plug in negative 1, I have to get the same answer. If I plug in 2, I get 4. If I plug in negative 2, I get 4. So an even function has symmetry across the y-axis, right? It's always going to be that way. If I even came up with a let's do a little more complicated one, like x to the 4th minus x squared. Let's see if it'll even show up on here. There we go. Let's just get rid of those for a minute. Okay, so here, this is even, right? X to the 4th minus x squared. And look what happens. It's symmetrical around the y-axis. So at 1 it's 0, at negative 1 it's 0. At 1/2 it's down there, at negative 1/2 it's down the same amount, right? Everything is the same on either side. So it's symmetrical. Even functions are always symmetrical. Let's look at an odd function and see what it looks like. So x cubed. Now, does this one have symmetry? It does. It's different symmetry. It's not a reflecting over something, right? So like Here at 1 it's up to 1, at -1 it's down to 1. At 2 it's up at 8, at -2 it's down at 8. So you see that there's whatever is up here, it's kind of like we could take this and rotate it 180 degrees over to here and it would land on itself. That is called symmetry around the origin. Okay, so it's not a flip, it's a rotate onto itself. If I rotated this 180 degrees, it would land on itself. That's called symmetry around the origin, and odd functions are always symmetrical around the origin. Okay, so here's your quiz question for 3.5c. Look at this function, f of x equals 3x cubed plus 5x minus 11, and tell me, is that function even, odd, or neither? Write your answer in Canvas on the quiz.